Have you ever just stopped and looked at a photo on your phone? You know, that perfect sunset or a hilarious face your friend made, and just marveled at it? But have you ever really thought about what that photo is? Well, it's not magic. It's actually a secret code. And today, we're gonna crack it.
So, here's the central mystery. Your phone, at its very heart, is just a super fancy collection of on-off switches. All it really understands is on or off, or in computer speak, ones and zeros. So how on earth does that incredibly simple language create the millions of colors and all the fine details in a photograph? It seems impossible, right? But the answer is actually pretty brilliant. You see, the solution isn't to try and teach the computer to see the whole sunset at once. Nope. Instead, the computer does something much, much smarter. It breaks that big, beautiful image down into the smallest possible pieces it can handle, tiny, manageable bits of information that it can understand. And those tiny pieces, well, they bring us to the fundamental building block of every single digital image. We are now entering the world of pixels. So, what exactly is a pixel? The best way to think about it is like a single tile in a giant mosaic. It's the smallest possible square of an image, and here's the key. It can only be one solid color. That photo on your phone that looks so perfectly smooth, it's actually a massive grid made of millions and millions of these tiny, single-colored squares. And you've totally seen this yourself. If you take any photo and just keep zooming in, eventually that smooth image just disappears, right? And you're left with a grid of colored squares. Yep, those are the pixels. So the big question is, how does the computer know what color to make each and every one of them? That's where the machine's own language comes in. Now that we've isolated one of these tiny squares, how do we tell the computer what color it's supposed to be? This is where that super simple language of zeros and ones finally gets its moment to shine. Okay, let's start with the absolute basics, a simple black and white image. The computer is told that the number 0 means off, as in no light, which creates a black pixel. And 1 means on, full light, which makes a white pixel. That's it. It's really that simple. And that right there is the crucial point. Everything a computer does, everything, boils down to this simple binary switch. By assigning a 1 or a 0 to each little pixel, it can start to build a whole picture, one tiny square at a time. But of course, our photos aren't just black and white, are they? So how do we make the jump from the simple on-off, black and white system to the millions of vibrant colors we see in our photos? Well, to do that, we need to expand the computer's vocabulary beyond just a single 0 and a single 1. The solution is to give each pixel a more complex instruction. So instead of just one digit, the computer uses a longer string of them. Each individual 1 or 0 in that string is called a bit, which, fun fact, is just short for binary digit. And this is where it gets really, really cool. Just look at how the possibilities explode. With one bit, you get two options, black or white. But just by adding a second bit, you suddenly have 4 possible combinations, 0, 0, 0, 1, 1, 0, and 1, 1. That's 4 different colors you can assign. The more bits you add, the number of colors just grows exponentially. And this is where the real magic happens. A standard color photo uses 24 bits of information for every single pixel. And that string of 24 ones and zeros, get this, it creates over 16.7 million possible color values. To put that into perspective, that's actually more distinct colors than the human eye can even perceive. Wild, right? Okay, so we've cracked the code for a single pixel. We know how it gets its color. Now it's time to zoom back out and see how millions of these tiny coded squares come together to create the bigger picture. So let's take a standard full HD photo, like what you'd see on your TV. It's a grid of 1920 pixels across by 1080 pixels down. If you do the math, that's over 2 million individual pixels. And remember, every single one of them has its own unique 24-bit code telling it precisely what color to be. And this is exactly why a 4K photo looks so much sharper and more detailed. It's not just a little bit better, it packs in roughly 4 times the number of pixels as a full HD image. We're talking over 8 million tiny color instructions, all working together to create a far more detailed and lifelike picture. So here's the big takeaway. That incredible, beautiful photo on your phone is, to the phone itself, nothing more than a very, very long and perfectly ordered list of binary codes.
It's basically a massive instruction manual with millions of tiny commands, one for each and every pixel you see.
And isn't that just the coolest part? This entire complex universe of digital photography, all the color, the detail, the emotion, it's all built from the simplest possible foundation, a single on or off switch, just repeated millions and millions of times over. It's an amazing fusion of pure art and pure logic. But it kind of leaves us with one final thought to chew on. If our most cherished photos are, at their core, just long strings of data, then what exactly is a memory in the digital age? It's something to think about the next time you tap your screen to capture a moment.